measures. Now we enter, these are degrees. That circles up there, it's degree measures, which is fine and everything's good, but all of a sudden they wanted to change this measure to something else. Okay? So something called, remember, most people probably heard about this radian. And when you write it, degree, we use the symbol. Radian, we use this RAD letter next to it. It's just like converting 1 centimeter to one, whatever, the point some feet, things like that. It's a conversion of a different unit. Well, that happens a lot because different countries use different metric system and things like that. In mathematicians have a different reason to use this one, which is the following. If you look at this measure of written in degree here, the number part, 180, without a degree attached to it, this is just a number, right? The pure number. The term for that is a magnitude. So we call the magnitude of this measure is 180, pure number, right? This magnitude is used a lot in physics and geometry to calculate something. So in physics, you use the magnitude of angle multiplied by the magnitude of a length or the magnitude of a gravitational force. Those magnitude enter the algebraic world and mingle together. And that's the one, it's a wonder. When they do that, they realize that if you change this unit to a slightly different thing, that magnitude together makes a nicer formula than degree measure. So they decided to switch the unit a little bit. And that's called radian, right? That's the motivation, whatever it is, and here's the master rule. So this is something you want to understand, and if you don't like understanding things, you can simply memorize it, whatever that it comes out of it. 180 degree. So what is rescale version? What is it? There's new. What is a new unit? Radian, RAD, right? RAD. So 180 degrees. How many radians, right? Does anybody remember this number? This is called 3.141592. That's all I know. But it goes forever, right? That number, that real number, that location to the right of the 0 in the number line has a name, right? That name is pi. Because the number is complicated, they decided to use the symbol instead of numerical approximation. Numerical approximation might give you a wrong impression. Once we begin to use this letter pi, it also gives the student a wrong impression. This pi is something like radian. It's not a number. It's some sort of symbol mathematicians prefer to use. But remember, pi is a number. It's so complicated, we decided to use a letter instead of writing and things like that. All right? So 180 degree is pi radian. That's a new unit. All we have to understand is now, algebraically, what is 1 radian? And one radian is how many degrees, and 1 degree is how many radian. From that, you can convert it freely. Your calculator usually have this conversion things built in it. But when I ask you in the test, convert this one, you want to show this formula, written down, not just answer, right? Okay, so here it is. This is a principle, and they figure out by looking at the geometry formulas, if you switch it like this, things are neater. Formula doesn't have to have a complicated proportionality multiplied to everywhere. So here is it's not hard to see what's going on here. You kind of treat this symbol degree as if it is something multiplied to 180 degree, RAD as if it is an x multiplied to number 3.14. So it's a pi times radian, as if you can treat it like that. If you once you treat it like this, the following formula makes sense. 180 is multiplied to degree. 1 degree multiplied by the magnitude 180 is 180 degree. Does that make sense? Now you divide that 180, you're going to end up at invisible 1 degree here. The magnitude plays like this. Pi was there already, and you're dividing both sides by the magnitude 180. Not degree, 180, the number itself. Then there was radian multiplied there anyway, right? Now 1 degree is a pi divided by 180, that number, right? Times a radian. So I want you to pull out your calculator if you have a calculator with you. And I don't have a calculator with me right now. I don't want to touch my phone. So please help me out with the converting things into numbers. So I'm going to be careful in here. Using this wavy symbol, what does that mean? Is not exactly right. But often this is what we care about. Numerical approximation of this number, right? Alright, so that's why there's a wavy symbol is. So in this class, clearly try to be as careful as possible, clearly understand the meaning of equal versus meaning of this approximation. So I want you to divide pi by 180, the actual number, down to 4, let's say 2 decimal digits this time. In test, I usually require down to 4 decimal places. So that must be 0 point something, right? 180 is a lot bigger number than 3 point something. So what are the 2 digits? Did you calculate that? Pi divided by 180. William, do you have a number?
Yeah.
2 digits, please.
0.017.
017. Yeah, better have one more digit, too many zeros in there. So radian, right? 1 degree. Can you imagine how tiny that 1 degree is? All things is 180, 90 degrees over here. Divided into 90 pieces is a tiny angle in there. Think about the protractor on which the angle is. So that's 0.01 radian there. All right, so what is the next formula? Is 1 radian, right? If I have a 1 radian, how many degree is it? So to convert right-hand side to 1 radian, you're going to divide both sides by pi. Is that right? The magnitude pi. Then you're going to end up at 180, and the magnitude is divided by what? Pi. These are numbers, right? Pi is not symbol. It's actually representing. So your name is Michael Harris? Is that right? Okay. All right. So there. I want you to go ahead and calculate this magnitude, 180 divided by pi. Forgot. So remember 45 degree? A little bit over that 45 degree, right? That's where that 1 radian is. Okay? So at this point, this is a formula I wanted to go by. What we are about to do is not hugely important for the test, but we need to understand what these things are, right? And then you feel better about this formula that you have to use and memorize. All right, 180 degrees pi radian. From there, many of you I know, you can just juggle quickly to get to this formula. But here's one way to memorize this formula. If you're converting degree into radian, it's all about pi and 180 degree. Which one goes to the numerator, which one goes to the denominator, all right? Let's remember that part. If you're converting to the radian, pi goes up there. If you're converting into the degree, 180 is going to be up there in the numerator, all right? So that's how the formula works, and you will see how this one works in action. So there was a question, so let's see. So at this point, our first exercise of the day, what would that be? Is a sketching. Go ahead and sketch 1 radian in the standard position, right? So sketch the angle of what measure? Did I just say? 1 radian in standard position, right? Yeah, standard position. What is standard position? Everybody remember standard position? All right, what I did is I first sketched using the dotted line with a 45 degree is. So 57 was fairly kind of 20 more degree or less. So I went about a little bit more. So that's rough location, right? At least you got to have somewhere around there, not over there in the second quadrant. That would be very wrong, right? All right. So, but this 1 radian is roughly how many degree again? Yeah, 57, 2.9 degree. That's the new unit. Very inconvenient, right? In terms of what you're used to, 1 radian. When you talk about 6 radian later, or how about 6 radian? Do you have any idea about where the 6 radian would that be? 2 pi is a 3.1 is a pi, right? So 2 pi would be 6.1. So it's very close to almost 1 rotation. So things like that. So I guess we'll get used to it eventually. But whenever you have no idea, you will convert it to degree so you can figure out roughly where that is. Things like that. All right. So that was our first exercise. And so here's some actual problem. I'm going to pull that up. And before I'm going to hide the formula, and in this class, when I'm asking you to do something, you try to remember the formula first. Make that attempt before you actually just take a look at your, try to remember the phone number before you just go to the contact phone number. That really helps you to your brain work better. All right. Let's read this problem together. Express 60 degrees in radian. That's part A, and part B is the other way around with a different angle. You can read the question correctly. Express 60 degree in radian. All right. So we are converting this into the radian, right? So what did I say about when it's into the radian? What goes to the numerator? Right, pi. So pi stays there, right? So let me actually, Let me do this the other way around. Pi goes to the numerator. What goes to the denominator? Degree. What degree is that? 180 degree. These two numbers never changes. Doesn't matter if it's a 60 degree, 80 degree. This factor is always there, right? And it's going to be radian. So what do you think I should multiply in front of this? This was 1 degree, remember? To get to 60 degree, you have to multiply the magnitude 60 there. And that's how it works. 1 radian multiplied by 60. No, this radian multiplied by 60, that will be the 60 degree. So you see some nice cancellation. This doesn't always happen. These are the very special angles. So this numbers has an exact expression. So I will leave the pi there. But what happened to the 60 and 180 degree in the denominator? Isn't that 3 times, right? So I will leave the 3 in there and radian. Now, I already introduced this one last time. Keeping the pi as it is, and actually not dividing by 3, but it's keeping the symbol divided by 3. What is this value called? Exact value. This is a form simplified exact value. When we say numeric value, you can turn this one into numeric value. I bet this is 1 point something. So let me have that number, 1.1047. So you see, I'm switching to approximation. So we are looking at 60 degree, which is 1.047 radian roughly. Remember, 54 degree was 1 radian, right? 54 something was 1 radian. So if you go a little bit more, you will reach 60 degree. That makes sense. Okay. So I'm doing that so that you remember this is not some sort of unit. Pi is not a unit or measure. This is a number that's playing in there, and mathematicians like to keep that pi in that form for special angles. All right? So do you have a question? Yeah. All right, why don't I make that second part into exercise then? So part B is your exercise. Okay, so I got 30 degrees, is that right? 180 divided by pi is a universal factor in this conversion. You multiply by the magnitude that's given, and that it switches. That's the rough idea. Okay? All right. That's that. So, this principle is clear now, but whenever the magnitude is in a slightly different shape, it might confuse us. So we're going to look at the problems they have. We're looking at exercise problem 3 to 14. Want to try 54, for example? All right, so I'm going to copy that part. I think the question is clear, so I'm just going to get that data there. We're converting it. If you could do this quickly, and you may try other problems that is listed here. Right now, we're trying number 4, and if you want, we can try 13. Let's do these two things together. Converting a degree to the radian. Now remember, what is involved in here is a pi and the degree, the 180, right? And factors of 180 will give you a nice value, but you can see 7.5 is involved in there, 54 degrees involved in there. Not sure if it factors out nicely. Then you might try numerical value into a Weber sign, right? You're not going to lose anything however you represent in my test, but you have to deal with the Weber sign. The computer has a little bit of limitation. So Well, let's look at the solutions. I guess the first step is the same, and it's all about the next thing. So I have the 54 the magnitude and multiply by the factor pi over 180, right? So it's about how this thing cancels. I first looked at 6 is a common factor. So 6, 9, and 30. Is that right? Factor it out. And 9 and 30 has also have a common factor. So 3, so I reduce to that. And 3 and 10 does not have any more common factor. And pi, we don't think about a common factor there. Pi is not a whole number, so it's multiplied there. So WebAssign might need this answer, 3 pi over 10, right? So is that exact value or numerical value? This is the exact form, right? 3 divided by 10, decimal is not neat. Actually, it needs a 0.3, but pi is there. So you can convert this entire 3 pi over 10 into a number, and you can write down the approximate radian there, right? 7.5, already in the decimal, I didn't think about canceling it, but maybe it's possible with lots of 5s in there. So does anybody try that this actually, if you want to do it exactly, this is a 75 divided by 10 times a pi divided by 180, right? So it has some factor of a 5 in there, so it might cancel, and you can reduce it into a nice form as well. Okay, so how does that, this is radian, so you see factor of 5, 2, and how does it go? 1 is at 15, is that right? If you divide it by 5, is that 15? And I have 3 factors as a 60, and it's a 5, and a 5 with a 12, is that right? 5 with a 1, and that is 12 in there. So I see it's a 1 divided by 24. That's the simplest cancellation you can get. Agree? 1 divided by 24. But pi was there, so I would rather put pi there on radian. So WebAssign might need this answer in exact form. But you can multiply 7.5 by pi and divide by 180 and get a numerical answer. That will be approximate solution. First, do your best to deal with those whole number factorization. If it is not really neat, maybe you can convert everything, including pi, into decimal numbers. So let's do the other way around. Is there any question? This is another set of exercise I want to do. Both of them, we did that, and here and there. First, I'm going to try something like this, 24. I want you to try that, 24. But I also want to try the 22. This usually confuses students because there's no pi in there, right? All right. So here's the formula just directly applied in there. It's about how the things cancel. I see 18, so I cancel that, so it leaves 10 up there as a factor. Pi cancels, so it's 50 degree. Make sense? 50 degree. And if you just use this entire symbol into a scientific calculator, that'll give you 50 as well. It happened to be the whole number answer, so you will get that. So sometimes you have your calculator converting fraction to, the decimal to the fraction. That'll also usually catch the decimal expression of a number whose denominator is fairly small, right? Then it's going to catch you correctly. The second one, 0.4 and 10 cancels, it becomes a 34 times 18. So I got 612 is number, and you multiply it. Is that right? Yeah. So you can leave it like that, 612 divided by pi. That's a number, right? What kind of number is that? It's close to 194 as a number. But it's an exact form. It's 600 divided by 12 divided by pi degree. So where is 194? First quadrant, second quadrant, third quadrant, fourth quadrant. 194? It's past 180 degree, right? So it's a third quadrant, right? Third quadrant. That's where that is. 180 to you is here. You have to go counterclockwise to get to third quadrant. Go past 180 degree. Make sense? All right, so we're not going to sketch that angle. So here, this new thing. All right, so 9:30. Part A is, let's read it together, find the angles that are coterminal with the angle theta of measure 30 degree, but they begin to use this notation. Angle is not a number, right? But if it is in the standard position, they treat angle as a number, right? Because that's all that matters when it's in the standard position. Okay, so that's why you use this notation equal, because it's in the standard position. All right, I know you can sketch the angles in 30 degree, right? So let's do that. And once you get used to it, it is not necessary to sketch it. If I want you to sketch it clearly, I will ask in the test, sketch it. I want to see this thing. So here is angle theta, which is 30 degree. All right, it's correctly sketched roughly. 90 degree divided by the three pieces. So what is a coterminal angle? Angle is rotated around a lot more than this, right? Or backward, however you rotate it around, you end up at exactly the same terminal side. That's what you want. So I'm going to use different color, such as here, blue. This is the initial side, and you rotate it around simplest fashion, which is different from this one, and you end up at here. We talked about it going backwards. This time I'm going to go forward. So go a little bit here. That's a one rotation, right? And then go a little bit more. That would be coterminal angle. Is that right? Okay. So there's this angle theta. I'm going to call that theta subscript 2. This is a Greek letter called theta. Right? All right. So I'm going to calculate this theta 2. Not as numbers, a principle is embedded in there. 30 degree was, so what do? We go once around, right? And then we go 30 degree more. That's how I describe it in there. So what is once around? Positive 360. And how much do we go more? 30 degree. Well, that's going to be our theta 2. So I wanted to use the same fashion, same orientation, same direction of rotation. Somebody come up with third one, which is different angle but coterminal to the 30 degree. What would you do? No, going the same direction. What would you do? Go around one more time, right? So that would be 360 degree times 2. That would be algebraic expression of going 2 around. You can calculate it. But plus 30 degree more. Now I'm not sketching it here. But once you sketch this one, is that clear that it goes one round, initial side, and 30 degree more? Things like that. So how about in general? So I'm going to call general answer theta. So I'm changing this theta to theta 1 maybe, so that I can use this theta as a general one. So I change that to theta 1, subscript 1. So in general, what's the idea? 360 times some rotation number, right? So you usually use n. But this n is called whole numbers, right? 1 and 2 and 3. Not 1.1, none of those, right? Whole numbers. And these are degrees, and plus 30 degree. That would do it, right? Where, even though n usually in mathematics represent whole numbers, and you have to specify it when you write it. So, where n is what? It's a whole number, right? It's a whole number. Is 0 included in the whole number, you think? I heard it's not. So whole number here is 1. So 0 whole number will do it, right? 0 means you don't go once around. You just go straight to the 30 degree. But somebody said that what about going backward? That also counts, right? So going backwards, if you think about it, is not 360, right? I'm going to use theta tilde. It's an accent symbol mathematicians like to use. So let's go backward, right? Not forward. So how do you write that backward? Negative 360, is that right? Degree plus or minus this time. So let's see. That's true. So I'm here in initial side, right? Going backward will arrive in here, right? The once around, back around, and here. If you're doing positive angle, you're going this way. If you're doing the negative angle, you will keep going to the counterclockwise, right? You want to get back to the 30 degree, right? Are we going to add 30 degree or we're going to subtract 30 degree? We're going to go this way, right? That's where the terminal side is. Which direction is it? Positive direction. So we're going to add or subtract? We're going to add 30 degree. Does that make sense? Right. So that would be written like this. 360 times negative 1 degree plus a 30. To put this one into the same form as this one, so that we can come up with the same formula. Does that make sense? Negative was there, I put it inside that invisible one negative. So what would be this one in here? Theta prime being 360 times negative 2. That would be backward 2 rotations, revolutions, and then actually, I can't do that for you guys, but at the end, last bit, are we going forward or backward to get to 30 degrees? Still forward, right? Because after these 2 backward rotation, you still end up at initial side. What you have to do from there is a positive rotation to get to the terminal side. So that thing doesn't change. All right? So negative 2, what about if I put in negative 3? Do you think that's going to work too? Right. So here's our final formula. So I'm doing this general formula in here. Theta can be actually doing 360 times n degree plus 30 degree, not only where n is a whole number works, but the negated whole number works as well, right? Yeah. So where n is, do you know a technical term that describes 0 and the whole number together with negated whole number, all together? Integer. Yeah, is an integer. That's the term. Now you see the 0, whole number, and the negative integers and positive integers. Those are usually mathematicians' preferred terms. I think this book also used those terms. Positive integers, negative integers, 0. Good? So the general formula of all the angles in the world that is a coterminal to the 30 degrees they started with looks like this. 360 times an integer plus 30 degree. Right? We constructed. These are all the thing. I'm going to confuse you a little bit. And in my point of view, the merit and the value of a mathematical education sits a lot in the logic. And it is the one that students often ignore. So I'm going to play a little bit with the logic. What I just did in here is that I constructed a bunch of angles that are all coterminal to 30 degrees, right? Is that right? But that's all that I could think of right now. But you have to sit back and think about, what if there's some coterminal angle that doesn't look like this? Is it possible? Is it opposite logic? This is what I came up with. That doesn't mean this is the coterminal angles. That's the logic I'm playing on here. All right? I came up with this group of answers, but is it possible that out there the angle is coterminal that I did not discover yet? The answer is no. But at least I want you to consider that kind of question. It's very important to understand mathematical theories. Does the question I throw in make sense? No? The answer is no. This is all, but it's worth asking yourself. All the coterminal angle looks like this, and everything looks like this is a coterminal angle. These two sentences not a priori implying each other. You have to think about it a little bit. All right, this is the answer. All right, what is the question here? Find angles that are coterminal. Find angles that are coterminal to standard. I don't know how many angles they want, but these are all, right? You can go in and plug in n equals 1, n equals negative 2015. You got this number. These are all coterminal to 30 degree. Does that make sense? Yeah. What if the angle is to find two angles? What would you plug in? N equals 1 and 2. That will be the answer. Any choice. So let's go to part B. Any question about the coterminal thing? I sense that many of you are a bit puzzled at this point. I don't know why. That's why I'm asking. Yes, go ahead. Yeah, if it's a 30 degree, they pointed out, this will be replaced with 120. If that's 120, that's exactly right. Yes. Right. That 30 came from that 30 there. Exactly. Any other question? All right, let's apply the same principle, right? It's just about different number to part B. What's different about part B? It's in radian. There's no degrees. A pi over 3 radian. Anybody remember, what is a pi? How many degrees is that? Pi. 180 divided by 3 pieces. 180 there in your mind divided by 3 pieces. What is it? 60 degree, right? Does that make sense? We didn't go through the formula, but because numbers are simple, you can sometimes do that. Yeah. This is really 60 degrees, right? But we're not going to use 60 degrees. We're going to stick to this the radian measure and apply the same principle in here. Okay? All right, here's a theta. And this time, I'm going to drop that unit, radian. Then you assume it's radian. All right. So where did 30 degree come from? That's given, right? What's given in here? Radian pi over what? 3. And with no measure in there. Make sense? That's the angle there. To get to that angle pi over 3, what do we do? Rotate around forward and backward, right? How is it expressed in terms of in algebraically? One rotation times what kind of number? Technical term? Integer, right? What is one rotation here? Not 360. 2 pi, right? Half rotation to you. Another half pi pi. That will be 2 pi is a full rotation. Remember, I think I didn't do this here before. One full rotation in radian is 2 pi radian and 360 degree, right? 2 pi radian. So, not that, what is it multiplied by? Another letter, right? What is that? N. And plus or minus? Plus, right? If the angle is given as a negative pi over 3, the negative pi over 3 sits right there. Exactly what it is. But this is not your full answer, right? You tag it with what? Where? Right? N is what kind of number? Integer. And this 2 pi n is also called integer multiple of 2 pi. Does that make sense? Integer multiple of 2 pi. They phrase it like that. So all the coterminal angle is a 3 pi plus integer multiple of 2 pi. That's one way to phrase it. Does that make sense? So how would you go and compute an angle? I'm going to actually do that in here. The computation could be a bit tricky. So I'm going to go ahead and try theta equals 2 pi times what? N equals 1, right? That would be one example. Plus pi over 3. Is that good? And web design might want the following answer. How do you combine this one together? Maybe you can factor out pi and look at in the following way. 2 plus 1/3 pi. Does that make sense? Pi is a quantity factored out. What's left is a better number, 2 plus 1/3. And you have to combine this one, right? Common denominator, what is it over there? 6, right? Plus 1/3 pi. Is that right? Yes. Put into common denominator. Now you can combine it. What is it? The numerator become 7. Denominator is not 6, right? It's a third of pieces. They're always 1/3. It's a kind of unit there. So that's there. 7 pi divided by 3 might be what WebAssign wants. Convert it to decimals. If I don't ask in my test compute exact value, then you have to do it this way. Yeah, but you know, this arithmetic is not what I'm really looking for in this course. But you never know what WebAssign wants, right? So if you got to in here, that will be I'm happiest person. If you got to that, and that's the arithmetic is not hugely important. So it makes sense? All right. Why don't you try one more exercise, which I'll do that here. That's your exercise. Another exercise is here. So try n equals -1. Just bit of arithmetic practice, right? What did I try before? N equals 1, right? try n equals -1. But do you remember the meaning of n equals 1 and n equals -1? Anybody remember the meaning of this? N represent what? Rotation, right? One rotation, forward, backward. That's what the meaning of this number here. So go ahead and try this theta with n equals -1. Sorry about not giving you enough time, but this is about arithmetic, right? I'm just going to cut off it and you can read it later. The answer was -5/3 pi. All right? So the same procedure. So those are the coterminal angles done in radian, done in degrees. Any question? Let me just read this problem on that side. 39 to 44 together, right? Find an angle. Oh, actually, I had to do this. I'm sorry about this. I need to do this example 3. Let's not skip this one. All right, here's a new problem. Still about coterminal angle. It's not about creating a coterminal angle. It's kind of reducing down to the certain coterminal angle. It's a slightly different problem. But that principle might give you a good idea. Right, imagine this angle that's given here. Let's read it together. Find an angle with a measure between 0 degree and 360 degree. In geometry, that's usually what that matters. But they want this 1,290 degree in motion. So we need that kind of thing. Don't think it's the same thing. It's coterminal. It's different angles. So actual angle is 1,290 degrees. But where's the coterminal? Once you put the coterminal, and you can look at it as a smaller angle, right? That's what we're doing. So 190 degree, I'm approaching more algebraically. I know some of you are very good with this. You can have a clear idea what to do with this thing. But here's one algebraic approach. If this 1,290 degrees is a coterminal to what we're looking for, which is theta, we don't know, right? That's what we're looking for. That small angle in there. How do you get to the 1290? You keep rotating forward and backward. So what goes in between these two? 360 times n rotation, right? Degree. Theta might have degree already in there. So you have to figure out what n goes in there and what is the theta that's small enough. This is called a division algorithm. This whole thing is called the division algorithm. You divide 1290 by 360. The quotient will be that n, and the remainder will be a number in between 0 and the divisor you're using, which is 360, therefore is perfectly fit to what they're asking for, right? So how are we going to calculate that n? What kind of number is n? Integer, right? So you're going to divide that 1290 by 360. Is it guaranteed this is going to be an integer? No, right? But you will get an integer part. So I want you to go in and use your calculator, get an integer part. What is this number? Sorry about this. N is not this number. N is not this number. We're going toward to the n. For that n, we're going to do the following thing. So I changed the symbol. N is not this one. You know where the 1290 come from, the 360 come from there. So what is this number? Can somebody tell me what this number is? Down to one decimal place? 3.6. Agree? So by looking at it here, that 3 is the integer part and 6 is the fractional part, right? What is that 3 is exactly that n. Okay? So if you actually divide this 1290, let me show you that algebraically. 1290 by 360, you see the 360 cancels there. But it's multiplicative here, so it leaves n. Theta is supposed to be smaller than 360, right? So what this becomes is that you see the 360 and 360 cancels, and n is an integer, right? Plus, what is this number? Some small number divided by 360. So sure, that's going to be less than 1. That's what you see over here in the 6. So I explained that what I claimed here is justified through this algebraic manipulation. But the conclusion is that the large angle is given, you divide by 360, right? And then you have integer part and fractional part. That integer part tells you what the rotation amount involved in there. That's a quick answer, and here's a justification. Does that make sense? All right, so how many rotation is involved in the 1290 degree? 3 rotation. So do you think we're going to subtract off that 3 rotation or add 3 rotation to 1290 degree? So here's a final bet. 1290 degrees there. So we're going to do something about 3 rotation. Is that right? Or we're going to add or subtract? We're going to subtract to get down to the smaller angle, right? Use your common sense if the given angle is a negative 1290 degree. If it is negative 1290 degree, what are you going to do? Are you going to add this notation to get into small? Think about it, right? All right. This one here is clearly subtracting, right? So can somebody do the arithmetic for me and get the angle? It's 210 degrees. Is that in between 0 and 360? Yeah. That's what they want. Okay, let's summarize it here. Large magnitude of angle is given. How do you reduce it down to small angle? Think about subtracting off copies of 360 or adding back in the copies of 360 until it got into that size. How do we efficiently do that? Just to divide it. That integer part will tell you how many multiples are involved in these rotations. Make sense? So this is how you do it. Apply the same thing we did. So here, same thing. Find an angle in between 0 and 2 pi. Isn't that the same thing? 0 degree and 360 degree, right? Good? Yeah. So let's try 10. 10 is not big, but we're going to pretend as if this is like, 1,000, right? Right, let's do number 48 together. You look at the 10, dimensionless number, right? Then what do we assume? It's a 10 radian, right? So 10 radian is going to be written in what form? We're looking for small angle theta in radian, right? But this is probably more than 0 and 2 pi. So what's involved? Going from small angle to large angle, coterminal angle. Rotation, right? How is this algebraically represented? 360, but here is radian, right? So 2 pi times n. N is an integer. Okay? It's all about, let's find n, then I can just subtract off of 10 radian, and there's our theta, right? Same principle goes, how do we calculate n? Carefully using different notation. N, for n, what do? We looked at 1290, right? Here is a 10 radian. Before it was 1290, it's 10 radian. Divided by rotation, 1 rotation, right? What is 1 rotation here? 2 pi. That'll tell us what? The rotation, number of rotations that's involved, right? God, I can't do this in my head. So why don't we do the 10 divided by, put the parentheses in your calculator, 10 parentheses divided by parentheses 2 times pi. Let me have that number. Approximation symbol, right? 1.6. What does that, what do we do with this number? We conclude about n, right? We conclude about n. What is n? 1. 1 rotation involved. Imagine that was 1,000, right? There's a lot trickier to juggle that in your head because some of you know pi is roughly 3.1, so I don't think there's more than 1 rotation involved. But if it's 1,000, it's harder, right? So this procedure will definitely get you the right number. Okay, now I have 10 radian there. There's more than 1 rotation involved. We're going to add rotations or subtract rotation here. We're going to subtract, right? 2 pi. So how many rotation are we subtracting? 1 rotation. That's where that 1 rotation goes, right there. And we're gonna guarantee that this guy is going to be in between 0 and 2 pi. It's calculated here. There's no way to combine I missed the radian here, pi minus 10 like that, right? That is the simplest, the exact form as it gets. So in exact form, it's going to be 10 minus 2 pi radian. In exact form, this is as best it gets, right? But it is not very gratifying for those people where that angle is, things like that, right? So let's actually calculate 10 minus 2 pi down to some radian decimal number. So I switch to the squiggly symbol. So what is 10 minus 2 pi in decimals? 3.716 radian. Thank you. I know where this one is. I know where 3.14 is. Remember where the 3.14 radian is? Over here to you. 3.14, almost 180, right? So where do you think the 3.7 is? Go a little bit further, somewhere down there, probably in third quadrant, right? I don't know exactly where, but I'm sure it's in the third quadrant. So just to give you an idea where it is, in a quadrant 3. Okay? That angle, 10 radian, is a coterminal to the somewhere angle down there in the third quadrant. And if you convert it to degree, and you have a more specific idea where that angle is located. Fair enough? Sorry that we still have like 5 minutes, so I'll use it. Find an angle 0 to the 360 degree coterminal with given angle. We already did the positive case. Let's pick negative 800, right? So we're going to do it together. So let's proceed in here together, not exercise. So what do we do? Negative 180 degree. Well, let's take time. Solution. Can you read it? Good enough. So magnitude is negative 800, right? That's magnitude. So what do we do to that magnitude to figure out how many rotation is involved? And we're going to divide by 360 first, right? 360. So I'm not writing it down all the procedure I had before, just kind of cutting down, just writing down the necessary information. So can you do that for me? 0, 0. It's a negative number, right? Negative 2.2. All right. What this really means is that negative 2 minus 0.2. So the fractional part is negative number. It's negated the whole thing, right? So I think to get to positive angle 0 under 360, I think probably you have to add 3 multiples, not negative 2 multiples. All right? So let's see what happens. So what is the integer part in here? Negative 2. And what do we do with that? The original angle 800, the negative 800 is there. So how do you get to the 0 and 360? Are you going to add rotation or keep subtracting a rotation? You have to add back in to get to that. So how many rotation do you think is involved in here? It's magnitude of that integer 2. It seems like 2 rotations involved, right? So I want you to go ahead and do this 2. Turns out it's not in between 0 and 360. Why don't you go ahead and actually calculate this? I don't think it is. Can somebody get the number for me? Here, negative 8 is small enough. I have a clear idea where that is, right? But what they wanted is that they want an angle in between 0 and 360, right? So where is this, in terms of quadrant, where is the negative 80 located? Fourth quadrant. How do you convert this one, sort of convert is not a good word, to angle coterminal to positive 0 and 360 degree? You're going to add one more 360 degree, right? Then it's going to do it. So the correct way of doing it when the angle is negative in our method is at 800, and you got that number 2 before, right? You always have to do one more because it's going to give you a magnitude between 0 and 360, not the correct sign. So you do one more rotation, and then you're going to get what? Is that 280? Is that right? 280. If you add 360 to negative 80, it's still one rotation. You're exactly in the same location as the terminal side of the angle before. So that's the same the coterminal angle, 280 overs. All right? I try to explain why you do one more. Now, once you understand, you know that if it is negative angle in this procedure, you have to add one more rotation to get to 0 and 360 degree. But this negative 80 is still meaningful information. We know exactly where it is. All right? Those are two different measures of the angles and how to deal with the angles that are coterminal to each other. So that's going to be the homework. Thank you.